Hello, I'm Alex Rude, and I'm going to be your host today. Welcome to February Variety Hour of 2025. It's the first Variety Hour of the year. And today is a special event because, as many of you might have heard or read, Steph O'Donnell finished her last day at Wild Labs recently, and we're going to be carving out some time today to honor and celebrate her and all the time and energy and leadership and strategy and joy and community and everything else that she's brought and put into Wild Labs over the last 10 years as she's been building it from the ground up. So we're having exciting Steph-themed quiz coming up during ad break, and going to leave some time for everybody to shower her with love and affection and thanks towards the end. We have some great speakers lined up today, as well as, like I said, a great ad break brought to you by Talia Speaker and the Wild Labs team. Our speed talks today are from Grace Melone, Esteban Rodofili, Stephanie Mitchell, and then Stefano Puliti's longer talk is going to be rounding out the event. So first up, I am going to pass it over to Grace to start things off by sharing her research on using computer vision to analyze bumblebee behaviors. I'm going to pass it over to you, Grace, to share your screen.
Great. Well, thank you so much, Alex, for having me. This is a really cool opportunity. I'm going to be talking to you all today about how we've been using computer vision to understand bumblebee thermoregulation under heat and nutrition stress. And I'd like to start by thanking my lab mates in the crawl lab, especially Acacia Tang and August, for their work helping this project come to be, and my stats consultant, Stephen. And then this work is funded by the USDA and University of Wisconsin. And then I always have to thank the bumblebees that we use for kind of giving their lives to science. So first, we'll talk about heat waves, why we're interested in them, and what they are. Heat waves are abnormally hot periods relative to the average local temperature, and heat waves are increasing in frequency and severity due to global warming. I probably don't really need to tell you that. We've all been experiencing this over the past 10 years or so. But why we study heat waves is because temperate ectotherms, like insects and like bumblebees, which I'll be talking about, may be more vulnerable to heat waves than average warming. So the like plus 1.5 degrees Celsius is not as dangerous as heat waves can be. Okay, now the fun part, we get to talk about bees. Bumblebees are an important wild and managed pollinator in temperate ecosystems, and they're a social system, which is super cool. And it means that they are able to collectively thermoregulate their nests. When it gets too hot, that induces fanning behavior, where they try to convectively cool the nest by flapping their wings really fast. And although we know that this behavior happens, we have very limited understanding about how this behavior changes throughout the course of a heat wave. And heat waves don't just happen for 4 hours, they can happen for multiple days. And so that's what we were really interested in studying. So first, we ask how fanning changes throughout a heat wave. And then second, if nutrition quality impacts thermoregulation, because we know that bumblebees are not just facing stress from heat, but also often from nutrition. Okay. So our kind of null hypothesis was that as the heat wave turns on in this red line here, that there would be an increase in fanning in response to increased temperature, but then they would just be able to maintain that throughout the entire heat wave. As there's this constant stress, they'll maintain a constant rate of fanning. But that seems a little unlikely because the bumblebees would also be experiencing thermal stress throughout this heat wave. And so what we otherwise expected was that fanning would actually decline throughout the heat wave. So although that they have this constant heat stress going on, they wouldn't be able to maintain fanning. And we expected this result to be stronger for the low resource bees, that they would decline in fanning faster and not reach as high of a fanning amount. Okay, so we use Bombus impatiens. This is a bee that is native and widespread in the eastern United States and is quickly becoming a model system. And we made, per round that we did, we made 16 microcolonies with 5 bees and about 3 brood cells per microcolony. So we take bees from this large colony and put them into little boxes, and they're able to kind of establish like mini colonies, and we're able to study their behavior that way. We exposed them to a 3-day heat wave at 35 degrees Celsius for, and we had a ramp rate of 0.1 degrees per minute. And I just want you to make a note that temperature does not change throughout the heat wave. And then our two nectar concentrations, so that's our high and low resources, were a 50% sucrose and 25% sucrose nectar. And we know that this 50% is preferred for bumblebees in the field and in lab. Okay. So then we get to kind of the harder part of setting up this experiment, how we recorded videos. So my lab mates August and Raphael and I set up this kind of monster rig to record videos. We used Raspberry Pis attached to Raspberry Pi cameras to autonomously record videos on a set schedule. We recorded about 50,000 individual videos of 20 seconds each, which is so much data. And so in order to not like drive me crazy, we use computer vision to be able to understand that data. Okay, so we tracked individuals throughout the experiment using Aruco tags that we kind of glue onto their thorax. And then we labeled a bunch of the bees, whether they were fanning or not fanning. And then we used that data to train an efficient B7 supervised classification model. So this is my little deep learning is happening figure. And then hopefully I'll be able to show you what that looks like. So these red bees are fanning in this video. Watch that one more time because it's cool. So that was really cool that that worked. It took a long time. But yeah, and I'm happy to talk a little bit more about that too later. So I'm just going to share this fanning result. Oops, okay. So on the y-axis, we have normalized fanning. So that's, lower, less fanning, higher, more fanning. And then time elapsed in the experiment since the heat wave started. And then the darker purple line is the high resource and the low is the pink. And so we do see, sorry, that fanning does decline throughout the heat wave, which is a really novel result and something that we would not have been able to access without using computer vision. And we find that bees in the high quality group fan more. Sorry, I'm getting over a cold. Sorry, I think I'll have to end there, but you guys can read these.
Well, thank you so much. I'm so sorry that you're not feeling well or getting over a cold. This is awesome, and I definitely have questions that I might put in the chat for you to answer, just to not make you speak. And I encourage other people to do the same. But what I will say is that I would love personally, and I think the Wild Labs team would as well, to see some reviews from you and your lab mates on Raspberry Pis and the Aruco tags that you guys used on the inventory, our wiki style database of conservation tech, which I will drop into the chat later on. But thank you so much for that presentation, Grace. Again, I hope you feel I hope you feel better. But thank you again for that talk. And next up, we have Esteban Rodofili, who is going to be introducing us to his project studying whale migration from space using satellite imagery. Very cool. Whenever you're ready, take it away.
Thanks, Alex. Hi, everyone. Thanks, everyone. Thanks for coming to my talk on automated detection and bearing measurement of migrating gray whales. My name is Esteban Rodofili, and this work was part of my PhD research at the University of Florida. I would like to start by thanking my co-authors, the University of Florida, the Melnick Fund, and the Nadeau Fund for funding this project, and it was recently published in Marine Mammal Science. This work aimed to develop an object-based image analysis, or OBIA, workflow to automatically detect migrating gray whales in their southbound migration off the California coast and extract the orientation of individuals in multispectral satellite imagery. We also aim to assess its utility for future efforts in the study of migration routes. We used a WorldView 3 image of 38 centimeters resolution of the coast of Central California from February 2015. We acquired 3 sections of the image with a total of 27 whales located manually. We conducted our OBIA analysis in eCognition Developer 9. OBIA entails segmenting an image into segments whose pixels are more similar among themselves than to those outside. You will see the whale from image A segmented in image B, actually. Let me see. I don't know if you see the click button, but here it is, essentially. After that, we use the segments of one of the image sections as samples, as you will see in image C, to train a support vector machine or SVM classifier to classify the segments of the other 2 image sections, alternating the 3 images. We use 3 classes: whale, water, whale in red, water in blue, and confounding objects in turquoise, which was mainly seafoam. We first used 202 classification features, ranging from the mean value of a particular band of the image in an object to shape, size, or texture features of such object. After a workflow with 202 features, we applied feature selection through a minimum redundancy, maximum relevance algorithm, and retained 15 features to do the same procedure in another SVM workflow. Here is an example of a detected whale fluke. Here is the whale fluke, and here is the actual detection. However, when contrasting to our manual count of whales, the workflows missed some whales, which yielding false negatives, and also had objects detected as whales that weren't whales, yielding false positives. The workflow with only the selected features yielded fewer false negatives and especially fewer false positives, having a lower false negative rate and a lower false positive over detectable rate. While false positives were still considerable, when dividing the image into grid cells to review in order to discard false positives, the grid cells to review were reduced to less than 3% of the cells for a full manual analysis of the imagery. We measured manually the bearings of whales, which you can see on the right over the map. And most whales were oriented in the southeastern quadrant as expected in the southbound migration. We also obtained from detected whales of the 15-feature workflow the main direction of their corresponding detected objects automatically, yielding the automated detect orientation measurements of the left map. In some cases, the automated measurement was taken from head to tail instead of from tail to head. So we calculated semi-automated measurements by adding or subtracted 180 degrees to correct this in some cases, which you will see in the map on the right. Both automated and semi-automated measurements were compared to manual measurements. Using Morse tests for paired circular data, we could not find statistically significant differences between manual and both automated and semi-automated orientation measurements. The results are promising for satellite image studies of migration routes by saving time in the detection of animals and measurement of their bearing under a semi-automated approach. Thank you so much.
Thank you so much. That is so cool. My question was, are any of these models or tools like open and accessible for other people to train them on other species besides gray whales?
Unfortunately, this one was done in eCognition, so beyond everything that is explained in the paper, eCognition is not a free software. So in that sense, you cannot share the actual code because there wasn't an actual code. It's more of a built-in environment. But for example, I do have a publication of manatees using object-based image analysis on Google Earth Engine that is freely available for everyone. and that has sharing of the image and the code and everything else.
So, well, if there are any other questions for Esteban, if you want to put them in the chat, and then I'll direct you back there to answer those. But that is super cool, and I also am curious about the manatee work because I love manatees. And
Thank you.
and thank you again, Esteban. And now we're going to move over to Stephanie Mitchell for our last speed talk, and she's going to be going through her work enhancing epidemic intelligence for wildlife disease surveillance in Kenya. So, Stephanie, whenever you're ready, you can take it away.
Thank you, Alex. And hi, everyone. My name is Stephanie Mitchell. I am a second-year PhD student at the University of Washington. So hello from Seattle this morning. And I'm going to be talking to you about Wildlife Health Watch, which is the parent project that my dissertation is nested within. So Wildlife Health Watch is in development with the Smithsonian National Zoo and with San Diego Zoo and many other partners, as you can see on the right-hand side of my screen. And I'm affiliated with the Smithsonian and with the University of Washington. So briefly, before I dive into more detail, Wildlife Health Watch is based on using syndromic surveillance. And for those of you not familiar with syndromic surveillance, it is a tool used in both human and veterinary medicine to use health-related data to identify potential health threats. So looking at different clusters of symptoms and what those symptoms could be leading us to believe in terms of infectious disease, or looking at different body systems to understand if there's injury going on, or let's say such as like poisonings or even snares. But syndromic surveillance is a little less specific than confirmatory diagnosis, and it's really based on its assumptions that the data are sensitive to changes in different disease or health threat levels. So just to give you a quick overview of the project. So again, Wildlife Health Watch is using syndromic surveillance on in situ wildlife in protected areas, and it is in its pilot phase at the moment. So one of the wonderful things about this tool is that it is a low-cost, non-invasive way of monitoring wildlife health, and it enables wildlife rangers to report observations in real time while patrolling. So Wildlife Health Watch is powered by Earth Ranger, for those of you familiar with Earth Ranger, and it is a health module that has been built within the Earth Ranger tool. So our goal is once we are through the pilot phase that it will be available to all Earth Ranger users. So Wildlife Health Watch is leveraging current technology that's being used within Kenya, and we have a three-step approach: reporting, epidemic intelligence, and response. So we are currently piloting this Earth Ranger Health module in, well, we started out in 17 protected areas over a 2-year period, but it has grown since then. And rangers are being trained to recognize and report disease symptoms in real-time transfer of data to relevant stakeholders. So then the goal is to use the Earth Ranger platform and artificial intelligence to show spatial and temporal distribution of reported cases or of health threats. And I apologize, I'm an infectious disease researcher, so I tend to default to disease, but there are other health threats that we are monitoring for as well. And lastly, then to improve response and developing participatory models for disease management or health threat management, and linking data to veterinary response mechanisms incorporated into a One Health approach. So for those of you who are unfamiliar with a One Health approach, I'll go ahead and give a plug for One Health here. I am in a One Health PhD program. So One Health is looking at the intersection and shared health between ecosystems, or the environment, people, and animals. So one of the wonderful things about Earth Ranger is we're hoping that on this platform, we can take Wildlife Health Watch and then feed into some other systems within Kenya, and really have an integrated health monitoring tool that expands beyond wildlife and would also incorporate domestic animals such as livestock or domestic dogs, and also incorporate human health. So how does Wildlife Health Watch work, and how could this feed into a national One Health surveillance system? So currently we have ranger reports, as you see at the top of that chain, and there are a lot of community members that communicate with the rangers on the conservancies, and a lot of times that's done through WhatsApp. It'd be great in the future if the tool could also receive direct inputs from community members, but then that is fed into the Wildlife Health Watch program, and that data is relayed to KWS in terms of wildlife and any wildlife monitoring. And then that data is relayed to the DVS in Kenya, who is in charge of all of animal health. And then that data will then be relayed to the zoonotic disease unit, which is a specialized team and unit that is investigating health in domestic animals, wildlife, and people. So what's my role? What am I doing here? So for part of my dissertation, I will be supporting epidemic intelligence to show how Wildlife Health Watch and artificial intelligence can be used to show spatial and temporal distribution of reported infectious diseases, as I'm focusing on infectious diseases. So my goal is to evaluate and quantify human-animal contact rates and wildlife domestic animal contact rates at key interfaces. And through that, I'm going to be developing some multi-species agent-based disease transmission models that are spatially explicit, focusing on rabies and anthrax to predict disease risk in humans, domestic animals, and wildlife on shared landscapes. So in order to do that, some of you may have seen my post asking about dog collars. I am going to be using some collaring data in conjunction with some qualitative data as well. So in order to support the tools approach with developing a participatory model for disease identification and management, we're going to be partnering with some pastoralist communities and evaluating the spatial placement of wildlife health surveillance to strengthen this One Health approach to zoonotic disease epidemic response. So using a One Health framework and a mixed methods approach, and this is where you may have seen some of what I was posting on Wild Labs, in order to understand how humans, wildlife, and livestock are all intersecting on these shared landscapes. I'm taking a mixed methods approach. And one of the ways I'm going to be doing that is gathering quantitative data through GPS collaring, which will be analyzed to assess interactions between domestic animals and wildlife. And as you may have seen, I was asking about small collars for domestic dogs. So I'll be collecting some of my own data on domestic animals and then using data that's already been collected on wildlife in order to build those models. And then I'd also like to take some qualitative data that I'll be gathering through focus group discussions to assess how people are interacting with domestic animals and wild animals as well, to really give that model some real-time parameters. And I'll be building on some community wildlife health work that has already been done by Dr. Angwini, who is part of our team. So I just want to take a moment and acknowledge everyone on our team and all of my collaborators and everyone who's been supporting me through this stage for my PhD, and just say thank you. And if you have any questions, feel free to reach out.
Thank you so much. There's a lot of interest in there's a lot of interest, I think, in this presentation based on the chat, which is really exciting to see. And I was thrilled to see your post asking about the dog collars. And I guess my question for you is, besides that that sort of question that we saw in the WildLabs on the WildLabs platform, are there any other aspects of this project or this work that you want people to connect with you about or collaborate on?
Yeah, thank you. That's a great question. So the models that I will be building for my dissertation work will be used to parameterize and train an AI tool that is hopefully going to be integrated within Wildlife Health Watch as we continue to develop the tool. And the goal is for us to have an AI component that is going to be then detecting thresholds of certain health threats and sending those alerts out to veterinary teams or human health teams a lot faster in order to improve response times. So anybody who's got really a good experience with or expertise in building out AI tools, please reach out. It is something our team's working on right now, and I'd love to chat.
Awesome. Yeah, there's some interested collaborators in the chat, which is very exciting. So I'm gonna pop you in there to address those. And now it is time for our ad break. So I'm gonna pass it over to Talia to take us through our ad break and our quiz for today.
Amazing. Thank you, Alex. I'm just getting my screen up and then share. All right, so for today's ad break, we have two announcements and kind of calls for engagement from our community managers program that Alex has been leading, which is very exciting. So first, I'm actually going to hand it over to Henry to talk a little bit about this call for presenters. Henry, you want to jump in?
Thanks so much, Talia. Thanks, Alex. Yeah, hi, everyone. I'd just like to take a minute out of this talk to talk about an exciting event we've got coming up, as you can see on the screen. So one common challenge faced all across the tech community, and this is something that we've seen with the WildLabs Awards at the moment as well, is navigating open source products. And more specifically, if we choose to make our research or the products developed from our work open source, how can we still generate income and commercialize these solutions? Because at the end of the day, If we don't have any funding, then we can't continue our work. So as I said, this is a really common challenge we see all over our community. And we recently asked this question on our funding and finance group forums, and just giving a shout out to our funding and finance group, which is run by myself, Frank van der Most, who I believe is here somewhere. He's usually here at Variety Hour, and Aurelie Polak as well. So our group is, and yet he's just posted in the chat, amazing. So our group, the Funding and Finance Group, is a dedicated space where you can ask questions and get advice about how to get your project and your work funded. But going back to the open source solutions question, the Funding and Finance Group and our friends at the Gathering for Open Science and Hardware, or GOSH, are planning an interactive webinar discussing the different ways you can make your open source solutions financially viable, also highlighting some of the barriers you might be facing there as well. So we're currently looking for presenters for this webinar. So if you have an inspiring story, or if you want to ask for help from our community and present, your work and your situation, then we would love to hear from you. Please do reach out to us. I think you can use the QR code there on the screen to register to become a speaker. And yeah, you'll have 10 minutes to speak about your work. Frank, I see you are in the chat, so please jump in if I've missed something. And yeah, we'll post our emails and all of our contact information in the chat. Thank you.
Wonderful. Thank you, Henry. And then one more exciting group announcement is from our Latin America community. Vanne, do you want to jump in and share about this?
Sure, thank you, Talia. So we are so happy with Juan Sebastián Ulloa, my co-group leader from this Latin America community, to announce this first virtual meeting. We are almost 90 people right now in the community, so we thought it would be a great moment to gather together. And we have Simone Dina from the Brazilian team that's participating in the X Prize Rainforest competition. So she will be talking about a bunch of different technologies for biodiversity monitoring. And then we aim to have an open discussion about how to continue building this community all together. So we hope to see you there, and it will be not next, March 13. 5 p.m. Brazilian team. So hope you can join us.
Wonderful. Thanks, Vanne. So now that we're wrapped up with announcements, as Alex teased at the beginning, we have a special quiz today honoring our beloved Stephanie O'Donnell, who, as many of you know, is moving on to her next adventures and recently left the WILDLABS team. So we wanted to do her right by honoring her with a little fun variety hour quiz on her way out. So true to Steph fashion, this is Taylor Swift themed to an extent, titled All Too Steph, How Well Do You Know Her? So please get ready. As always, drop your answers in the chat. Alex, can you help looking at the chat messages because I can't see them super clearly? So let's get started. Obviously, Steph is not allowed to participate. That's clear. Sorry, Steph. Okay, question 1. How long was Steph working with WILDLABS? 10 years, 8.5 years, 12 years, or infinity?
Well, we have Frank guessed all of the answers for every question ahead of time. I'm getting a lot of C's. I'm getting some 12, which is also C. Adrian asking if we can participate, if WILDLABS team members can participate.
If any WILDLABS team members don't know the answers, you can say them, but I'm pretty sure you all know most of the answers.
It's mostly a mix of C. It's mostly C is what I'm seeing.
Okay.
As well as some D's thrown in and a few B's.
Steph, would you like to say something?
I just want to call out one of our steering group members overestimating the timeline, which made me laugh a lot. Adrian, you can participate. Why not?
D. All right. The answer to this one is A, 10 years. A perfect 10.
I straight up said at the beginning of this call that she's been building it for the last 10 years, but that's okay.
Yep. Steph was hired to manage the WILDLABS community after we were launched in 2015.
Fun fact.
Okay. Question 2. Who is Steph's dog, Bill, named after? Bill Clinton, Billabong Surf Company, Bill Weasley, or Dollar Bills?
Steph is mortified. We're getting one answer of A, a C, somebody that wants it to be D, B. It's a whole mix of answers.
B.
Jake is exasperated at the possibility that it could be Bill Clinton.
All right. So the answer to this one is C, Bill Weasley. And Bill has been and will remain to be the Wild Labs mascot. So if you have not seen him, go find Steph's social media.
Wish he was named after Bill Clinton. That would be really funny.
Okay, question 3. What is Steph's favorite Taylor Swift era? Red, Fearless, Also Fearless, or Reputation? I think it was doing me to have Fearless fans.
We got some B's, we got some D's. We got a C, which is the same as B. Dan is asking if C means
Yeah,
Fearless
Fearless
Taylor's
me.
version, which we're gonna say, yeah, it does.
Good clarification.
There's not consensus.
Version. All
Adrian
right,
asking who's Taylor Swift.
Adrian, you're kicked out of the meeting. Please leave. Question 3, the answer is D, Reputation. A Steph classic. All right, question 4. Which of the following is not one of Steph's go-to hobbies or side gigs? Miniaturist, clothing maker, wedding photographer, or illustrator? A, B.
A, some B. A lot of A's, a lot of B's.
More A's, more B's. Okay, so the answer to this one is A. The community knows her well. Makes amazing clothes that are always conversation starters at meetings and conferences. She is an incredible wedding photographer. She also photographed my wedding, and I will cherish the photos for the rest of my life. And she's also an amazing illustrator with published work in like children's books and lots of stuff. You can reach out if you want some illustrations. All right, question 5, true or false? Steph was on a reality TV show. You're welcome, Steph.
Harley says true. A lot of people are laughing. True, true, true.
True. Yeah,
Getting lots of
our
trues.
community knows stuff. Well, yes, in fact, she was on a reality TV show. Follow-up question. Which type of reality TV show was it? Boat renovation competition, Australian baking show, Farmer Wants a Wife, or Survivalist? All of the above. A, D, A.
A lot of people thinking boat renovation and Australian baking.
I would argue she could win a boat renovation competition. Maybe that's her next challenge. But the incredible and true answer is C, Farmer Wants a Wife. Google it, folks. You will not regret it. Steph, we love you. Sorry for embarrassing you, but this felt like the proper way to send you off. Thank you for everything you've done.
What a lovely, lovely wrap up. And fortunately, I don't feel embarrassed about any of those things.
I told you, it was fun.
They're good fun facts, and we were pretty nice, I would say.
I feel like you were very nice. I feel like there was a lot more under the that could have been shown. Yes, I feel like I didn't need to defend Bill's name. Bill was named after Bill Weasley, not because I'm a massive Harry Potter fan in like a really dorky way, but also I sort of am. I just wanted a really chill border collie, and it was the chillest book character I could think of. That's all. But yes. Wait, am I saying something here or am I saying something?
I think we're gonna do our last talk first and then throw back to you if that works.
Yeah, I don't have
you can process the quiz experience and then reflect on it in the last 5 minutes.
What question?
Alex, I'll hand it back over.
Okay, awesome. Well, thank you for leading the quiz and the ad break, Talia. Now for our last long talk, or our first long talk and the last long talk, we are going to hand it over to Stefano Puliti, who is going to talk to us about open science for 3D forest vision.
Hello, thanks Alex for having me here. Yes, so again, feeling like a fish out of water in a community of people looking at a lot about animals. I will talk about trees. So I'm Stefano and I work in Norway at NIBIO in the National Forest Inventory Department. And the work I'll present here, it's largely part of collaboration that I have with my colleagues Erasmus, Binbin, and Maciej, which is our dream AI forest team. And it's about 3D trees and 3D forests. And how do we get there? We shoot lasers at trees, and we record their coordinates of all of these laser pulses, and that's how we get these beautiful representations of trees. And this work is largely funded by Smart Forest, which is funded by the Norwegian Research Council. And so what we do is basically we want to see the forest for the trees. I know that many will not like that, but actually that's what we really want to do, and what has been our challenge for about 5 years. And so we collect all this LiDAR data over forests, and as you see, they look beautiful. We see all these trees. The trees, however, they don't have these beautiful colors in the raw data that we get. They are just points in space. So what we want to do is that we want to, first of all, segment each of these trees so that we can start to talk to each of these trees and interrogate them about what they represent in this forest. And then once we know about the individuals, we can then say something about the community. So once we segment the trees, then we want to extract biometrics for these trees. And these include species, include height, ground volume, it includes the health of the species of the tree, the age, the growth, and many aspects that are relevant for ensuring a better management of the forest, both for conservation purposes, or for productive purposes, or in general, multi-purpose use of forests. So this is our overarching goal that we've been aiming at for the past 5 years. But let's dive a little bit in where this started, where our open science effort started. And that was about during COVID, so about 5 years ago. And I had wrote a paper. I thought it was fantastic at the time, and then submitted it to a journal, and then this was the answer. Big fat rejection, which of course in the beginning you think, oh, this is very unfair, this doesn't make any sense. And then going through actually the revision, the main criticism was that we had a very small site with few trees, and our findings would not be really transferable beyond our site. And taking that in and digesting that, I started to think a little bit, how can we address this? And then another negative thing came, COVID. So then we were all stuck in our offices, and then all the massive globalized world became very small. And then I felt this urge to really connect with some of the greater community that was out there. So then I started sending paper airplanes around the world, and then hoping that there would be people around the world that would be able to share these data, so that finally that paper could be accepted in a way that and that it would address those comments from those reviewers. So actually turned out that many of those paper airplanes did come back, and that was a fantastic understanding for me of the fantastic community that actually was out there. And people were really eager to share data. Unfortunately, many were eager to share data that was useless. So was a lot of work also on kind of thresholding and finding what was the data that we needed and how do we do that. So that took a lot of time. So it's very easy to send out emails and get emails back, but actually to start working and compiling this data, it's very time consuming, something that took me about 5 years to learn. And then we started compiling these data sets. While the first one was this, we called it the 4 instance data set. So we called the overall family of data sets, they are the 4 family. And the first one is the 4 instance, which is a collection of point clouds, forest point clouds, where each tree it's individually segmented, and then different parts of the tree are also segmented. So it's useful for both instance and panoptic segmentation. and it comprises about 1,000 trees from different biomes and from different also type of management. And the data was published in an archive paper, and it's available on Zenodo. And the second data set, which I guess is what connects me a little bit to why I was invited here, it's a recently published paper in Methods in Ecology and Evolution, where we compiled this data set of individual trees with associated tree species. And our goal was to benchmark individual tree species classification. So in this case, we managed to collect 20,000 trees covering about 33 species, mostly around Europe, but also from other continents, and also from different sensors and different platforms. We wanted to remain fairly agnostic in regard to what data one can throw at the models that can be developed using this data set. And also these are available on Zenodo. So what we did after compiling the data sets is that we started developing methods. So we took these data sets, and then what we wanted to do initially, the first challenge that we had, and there was a long-standing challenge for about 20 years, no one really knew how to accurately segment individual trees. So we developed two state-of-the-art deep learning models for instance segmentation of forest point clouds. And that took a lot of effort, but finally we did start to obtain fairly good results. And we are still in the process of making these better and more applicable. Now we're looking at corner cases like tropical forests and stuff that you think that would be totally unreasonable to segment. And then in regards to species, this is what we did in the paper that I mentioned before. We actually we had a data science competition, and we benchmarked all kind of the main methods that had been proposed until today. So basically we converged in 5 months. We were able to converge on the most suitable methods to classify tree species starting from these point clouds, a work that hadn't been achieved in 5 years of research before by iterations on separate data sets. So very important to have this kind of common benchmark data sets attached with no kind of strings attached. And then, so that was what we had initially intended to develop the data sets for. And then suddenly new ideas came, and then people started using our data sets for new things. So suddenly now we are using this first species data set for generative AI, generative point cloud AI. So basically we want to create a virtual forest that doesn't exist, but that has certain characteristics that can be used for simulations. So then we can take all of these trees and generate new ones based on this library of trees that we developed. Another possible use that we are looking into is also for developing allometric models. So foresters are obsessed with this diameter at breast height, which is the one measure that we were able to get until now before all this laser scanning came about. So it remains still important. So for example, if we want to predict diameter, but based on the crown of the tree, so then this is one of the ways that we can also use these data sets. So to conclude, I would like to just have a little reflection on the importance of open science nowadays. And I think Henry already pointed at it. I think it's crucial that we focus on open science, and especially PhDs and the new generation of researchers that are coming out. Because science as we know it, as this public good that it's open to everyone, that creates knowledge that it's available to everyone, it's actually being challenged where we have these big corporations, big tech, that is where the big advances in AI are being made. It's really challenging and competing with the purpose of public good science. So there are basically these techno-political borders that are rising, and it's more and more challenging to collaborate beyond these borders. So I think that scientists have really a role nowadays to take these walls down and to actually create communities that go well beyond these borders. So in addition to those simple challenges that we have nowadays, like climate change and biodiversity loss, those are easy to solve, right? But we also have these geopolitical challenges that we also have to address, and we cannot look away anymore, right? So I think it's really important that the new generation looks at these things in a serious way, and that looks at how we build together something that is useful for the public good. Because regardless of this fair principle, and unfortunately, like these big companies like Fair, Meta, right? They start to use this name, OpenAI, and these names, they start to really be damaged by this big tech. Meta, yes, they publish a lot of their models, but they publish none of their data. So their reproducibility of the methods is just not there. So it's up to us to really make this available to everyone and usable by everyone. And regarding to the question of how does one commercialize this data, I think that it's a question that will get solved by itself. Once you are open, things come back to you. So don't worry about being open, and just share what you have with no strings attached and link to your colleagues. And to conclude, I would like to introduce this new EU project that we started and I'm coordinating, which is called Single Tree, and we'll be of these things in more detail. We'll be developing a lot of more advanced point cloud and 3D computer vision. So tune in and follow those channels if you are interested in forest and 3D stuff. Thank you very much.
Thank you so much. That was so incredible. And I'm loving this like common theme through some of these presentations about community engagement and power of community, because that's obviously what we're all about here. And I think that ties in really nicely to open source solutions and funding and finance group call out that Henry mentioned during the ad break. One question I have is, I know that you mentioned that most of those data sets are from North America and Europe. Are there what can people do, / is there any interest, / are there any plans to get more data from other continents in the global south, / I guess what can people do to get that data over to you guys to build out a more well-rounded set?
Yeah, so we're always very open, and we're all continuously working on updating these data sets. Now we're working on the 4 species 100K. The challenge is a little bit the accessibility to these kind of scanners, right? That is not super cheap. It is becoming a lot cheaper. So there will be definitely developments in the future. So anyone that is willing to collaborate is very welcome to get in touch with us, and we're very happy to include anyone in co-authorship. And really, I think it's not so much about that. It's really about creating communities and things that are long-standing.
Amazing. Well, thank you so much again. If anybody else has any questions, you feel free to pop them in the chat, and I will direct you over there to answer them. And actually, no, we have one question that just came in, and we have a few minutes to answer it before we pass things over to Steph. Simone, do you want to ask your question, or we can ask it for you?
So is this is the manual segmentation of the point clouds also a challenge to get the data? Yeah, so basically that used to be a bit of a challenge, but now we can run basically those segmentation models that we developed before also on non-segmented point clouds. So we accept also point clouds that are not segmented, and we will soon have some data calls out. So keep your ears open or your eyes open. Will be stuff popping up on social medias.
Nice. Oh, we have a follow-up question. Do the segmentation models work with non-European data?
Yes. We train them not just with European data. The reason why we have mostly European data is that honestly, we haven't been so successful in getting data out of the US, mainly because that's where most of the other data has been collected, but there is a bit more restrictive policy access to the data, for what I understand in the US. So, and whenever I hear like people that want to sign contracts and so on, then for me it all falls apart, right? Like either it's without strings, or if it gets complicated, then it becomes really not an effort that is worthwhile, because it's already a massive effort to compile this data.
For sure. Yeah. Well, thank you so much. I'm looking forward to seeing what else comes out of that with the 10,000. I forgot what the full title was, but 10,000 is a crazy number. And that is super exciting. Congratulations again. And thank you for coming and talking. And so for the last few minutes, I'm going to pass things over to Steph now that she's had some time to digest the quiz and maybe come up with a few words. But also I think it'd be nice for this to be maybe like an open thing for people to say nice things to Steph as well, perhaps.
Thanks, Alex. I don't have 5 minutes of commentary, I don't think, but I think I don't really have words for how Wild Labs has, like, what it's been like working with Wild Labs in this community for the last few years. It's just been, oh, I'm gonna get really emotional. Oh, I didn't expect that. We might need to cut this from the recording. It has been such, like, I think I wrote all of this in my LinkedIn post, and it kind of captures how I feel about it. Like, I've loved so much the last 10 years working with this community. I'm actually shocked I'm this emotional. Anyway, yes, I do. Thank you, Alex. I don't need 5 minutes. What I can say is I've had such, like, it has been so much fun, more than anything else, to work in this job, work with this team, and like with this community. I know I'm not going anywhere. I'm like literally gonna be at Variety Hour and like in the same events. So I don't know why this is like so emotional. And if this is your first Variety Hour, can I apologize for this introduction into this community? What a ridiculous, like, it's not normally like this. We're normally chill. But just to say, it's been such an honor and such joy for the last 10 years to help do what I can and what our team can to like listen to you guys and create spaces and programs that just it's not always like this. Stop lying. To just have the space to be creative and like listen to what you guys need and what you've told us, and to do what we can to mobilize resources, design programs, create spaces that actually answer some of those needs. And I think that this job and I think our whole team feels like this. And I know I've left the team, but you're still going to be forever part of my team. It's such a privilege to not be driven by one organization's priorities or one project's needs, or have a really narrow viewpoint. The real beauty and joy of working with Wild Labs was that we got to talk to everyone, and our only goal was to help everyone. That was the job. And so I think it's been enormously challenging, and like I think what our team has done with very little resource and a really small team, and with like, it has been incredible. But one of the things that really struck me from the comments I've been getting back and people messaging me has just been like, as news has spread that I'm moving on to different pastures, not greener, just different, has just been this enormous realization and appreciation of truly how many people helped build Wild Labs over the last 10 years. Not just the people who had Wild Labs in their job title and were employed by us, but like the community that built this community is huge over the last 10 years. And it has just been so joyful to work with so many people, and that it's not something that I created alone and not something that I own alone and can take credit for at all. It was the joint effort of hundreds of people over the last 10 years, and that I'm stepping back now means I'm still part of the community. I'm just not leading anymore, and that other people will take my place. And the first person who will do that is Talia. And I'm so proud and like so excited to see what you do with WILDLABS and where you take this community, and interested to see how we'll end up working together in different ways and different formats. So yeah, I just want to say a big thank you to everyone, and I hope that we'll keep. I did need 5 minutes. Good Lord. Okay. You knew me, Alex. You always know. You always know. I hope we continue to keep working together. I said that I was just going to be chilling out for like the next 6, 12, 18 months, and I'm a liar. It's been 2 weeks, and I've found my way into some interesting spaces and overcommitted myself already. But the main thing I'm going to be working on from now on is the Global Wildlife new reality show. Literally, Dan, it was a strong possibility that I would go become a boat influencer. I feel like I could become one in 6 months really effectively, but no, I'm going to go work. I'm going to be working with the Global Wildlife Program at the World Bank, which is as I'm finding my way into it, feels kind of like WILDLABS. And so hopefully there's going to be lots of linkages that we can create together. It's a very similar sort of community building role. So I'm really excited. But I will be popping along to as many variety hours in many spaces. And I'll drop my new email into the chat if you guys want to connect. But just my final thing is a big thank you, and what an awesome last 10 years this has been, and I can't wait to see what's coming up for the team, for WILDLABS, and for me as well. So thanks everyone.
Well, thank you, Steph. I'm happy that you took the full 5 minutes. That was very, very sweet, and we're gonna miss you. But like you said, you're gonna be around, so it'll be different, and we're so thrilled for you and so thrilled for Talia, and it's an exciting time for everybody. Thank you for everything that you've done. Everybody feel free to love up on Steph in the chat. And thank you everybody for joining and for our speakers and their lovely presentations. I'm going to end the recording now, but everybody's invited to stick around for after hours for a more casual conversation about things that the presentations we heard today or anything else, including reality TV shows, but not limited to that. So thank you for coming, and we will see you next month on March 26th.